For thousands of years, mankind has wondered, are there planets around other stars? Is there life out there? But with the help of our telescopes, we came to know that there are innumerable planets in the universe, which are orbiting other stars like our Sun. When we explored distant worlds with our new telescopes, we found smaller planets that have never been discovered before, indicating that galaxies are full of planets, crazy worlds that we didn't predict, things that we hadn't imagined. We find planets orbiting so close to their parent star that the star-facing side has temperatures over that required to melt iron. The planets have an entire hemisphere that's like a liquid ocean, but not an ocean of water. It's an ocean of molten rock. We see planets that are orbiting not one, but two stars. But to find life on distant planets, we have to study the planets deeply, which requires a very powerful telescope.
And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Before the launch of the James Webb telescope, we didn't know much about the exoplanet's atmosphere. With our previous telescopes, we could not study the atmospheres of the distant world in depth. But now with the Webb telescope, we are studying the atmospheres of exoplanets in great detail. Recently, the Webb telescope has done stunning discoveries about distant worlds. So, what are those stunning discoveries? Well, it has captured the first clear evidence of carbon dioxide in the atmosphere of a planet outside the solar system, named JWST-39. Webb also found some unexpected molecules in the atmosphere of a failed star. But the discovery which surprised everyone is that the Webb telescope found something mysterious in JWST-39b's atmosphere that was not predicted by the basic model. The researchers aren't sure yet what this mysterious object may be, but they are working to figure out with additional data from JWST and different models. Before knowing more about these discoveries, let's take a look at how the Webb telescope studied the atmospheres of distant worlds with the help of the transient method.
How do we learn about a planet's atmosphere? How do we know what's in the atmosphere of an exoplanet? The majority of known exoplanets have been discovered because they partially block the light of their host star. This is called a transit. During a transit, some of the star's light travels through the planet's atmosphere and gets absorbed. The light that survives carries information about the planet across light years of space where it reaches our telescopes. However, the planet is very small relative to the star, so it is still very difficult to detect, which is why we need a big telescope to be sure to capture this tiny bit of light. So how do we use a telescope to read transit light? Stars emit light at many wavelengths. Like a prism makes a rainbow, we can separate light into its separate wavelengths. This is called a spectrum. Visible light appears to our eyes as the colors of the rainbow, but beyond visible light there are many wavelengths we cannot see. Now back to the transiting planet. As light is traveling through the planet's atmosphere, some wavelengths get absorbed. Which wavelengths get absorbed depends on which molecules are in the planet's atmosphere. For example, carbon monoxide molecules will capture different wavelengths than water vapor molecules. So when we look at that planet in front of the star, some of the wavelengths of the starlight will be missing, depending on which molecules are in the atmosphere of the planet. Learning about the atmospheres of other worlds is how we identify those that could potentially support life, bringing us another step closer to answering one of humanity's oldest questions. Are we alone?
Well, using this transient method, the Webb telescope has spotted carbon dioxide in the atmosphere of a planet named JWST-39b, around 700 light-years away from Earth. This is the first time this compound has been found in any exoplanet, WST-39b is huge. It has a mass similar to Saturn's, and a diameter 1.3 times that of Jupiter. It is too close to its star that its average temperature is around 900 degrees Celsius. The researchers found that WST-39b has more carbon and oxygen than its host star, indicating that it didn't form when gas around the star collapsed all at once. But rather, its rocky core formed first, and then accreted the gas that makes up its atmosphere. This is similar to how we think the planets in our solar system formed. But the interesting discovery is that, aside from carbon dioxide, the researchers found something mysterious there. They saw another bump in their data, which indicates that something unexpected in WST-39b's atmosphere was absorbing some of the sunlight. One of the Webb scientists said that, "We found something else there, some other molecule, or some kind of cloud or haze, or maybe something else, that's not predicted by the basic model." Scientists are not sure yet what this mysterious molecule may be, but it is absorbing a big portion of starlight. Scientists are working to figure it out, with additional data from JWST and different models. In addition to this, Webb also detected the highest fidelity spectrum to date of a planetary mass object named VHS 1256b. It is a young brown dwarf companion, about 40 light-years away. This spectrum shows clear evidence for disequilibrium chemistry and clouds, as well as clear detections of H2O, CH4, CO, and prominent Na and K lines. Equally exciting, scientists found silicate clouds, the first such detection for a planetary mass companion. Webb scientist Hinckley said, "This is the greatest spectrum ever obtained of a substellar companion. We have never seen anything like it." Also, recently astronomers have revealed the first photograph of an exoplanet, taken by the James Webb telescope. This exoplanet is a gas giant, meaning it has no rocky surface, and could not be habitable. The image as seen through 4 different light filters shows how Webb's powerful infrared gaze can easily capture worlds beyond our solar system. This exoplanet in Webb's image, called HIP 65426b, is about 6 to 8 times the mass of Jupiter. It is young as planets go, about 15 to 20 million years old, compared to our 4.5 billion-year-old Earth. I think what is most exciting is that we've only just begun. There are many more images of exoplanets to come that will shape our overall understanding of their physics, chemistry, and formation. We may even discover previously unknown planets too.